One of last month's biggest astronomy stories was, as you may recall, K2-18b. Although this exoplanet was discovered years ago, recent findings have been nothing short of surprising. Organic compounds have been detected in the atmosphere of K2-18b, an exoplanet located 124 light-years from Earth. These compounds are the same as those produced by marine life here on Earth. Naturally, the news sparked a wave of speculation. Some claim that K2-18b might be an ocean planet with vast seas, and those seas might be teeming with life. In their depths, there could be algae, plants, maybe even complex organisms. People were excited, but others asked a very logical question. How can we possibly know that there's life on a planet 124 light-years away? And they're not wrong to ask. After all, we still can't confidently say whether there's life on Mars, Venus, or even other planets much closer to us. So how can we be so sure about something that's hundreds of light-years away? That's exactly the question I'll be answering in today's video. How can we detect signs of life on such distant exoplanets? And just how reliable is the evidence? I'll explain all of this in simple but thorough detail. But first, let's quickly talk about how we discover these distant worlds, because the methods we use to find exoplanets are closely tied to the methods we use to search for life on them. Let me start by saying this. We've discovered thousands of exoplanets, but we've barely seen any of them directly. Yes, thanks to some advanced techniques developed in recent years, we can partially observe a few nearby exoplanets, but actually seeing their atmospheres or surface features, that's currently impossible. All we can detect is faint light reflected from their host stars. We can't see these planets the way we see Mars, Jupiter, Saturn, Neptune, or Pluto. Why? Because they're unimaginably far away. So if we can't even see them, how do we know they exist? How can we estimate their species, atmosphere, or surface conditions? Well, while we can't see the planets themselves, we can observe their effects. There are three main techniques for detecting exoplanets. The first is by measuring their gravitational influence on their host stars. You know that the moon orbits Earth because it's caught in Earth's gravitational pull. But the moon also exerts a small gravitational pull on Earth. It makes our planet wobble slightly as it orbits the sun. Planets like Earth and Jupiter do the same thing to the sun, ever so slightly. By using extremely sensitive instruments, we can detect these tiny wobbles in distant stars. When we see that, we can confidently say something massive is orbiting that star. With enough analysis and mathematical modeling, we can estimate how many planets are there and even their masses. The second method is spectroscopy, and there are two main types. The first is transit spectroscopy. When we want to analyze a star's chemical composition, we look at its light spectrum, essentially separating the light into different wavelengths. This spectrum tells us a lot about the star's chemical makeup. But if something passes in front of that star while we're measuring, we'll notice it, a shadow or dip in brightness. If this happens on a regular schedule, we know there's a planet orbiting the star. That dip, that tiny eclipse, is caused by the planet. Just like how the moon blocks the sun during a solar eclipse, a transiting planet blocks a bit of its star's light. Using this method, we can gather crucial information about the planet. The third method is direct spectroscopy. In this method, we block out the star's light using special instruments so that we can see objects around it more clearly, like planets that reflect the star's light. This is our clearest technique for indirectly seeing exoplanets. Now that we understand how we discover exoplanets, let's return to the big question. How can we know what's in the atmosphere of a planet millions or billions of kilometers away? How can we tell if it's habitable or even inhabited? The key lies in where the planet orbits. Earth, for example, lies in the habitable zone of our sun. Not too hot, not too cold. Other stars also have such zones. That's where exoplanet hunters look first. Now, even though we can't directly see these planets, we can detect their shadows when they transit their stars. During this moment, light from the star passes through the planet's atmosphere, if it has one. This starlight is subtly altered as it filters through gases, molecules, and compounds. Certain frequencies of light are absorbed. And these absorption lines show up in the spectrum we analyze. From these spectral fingerprints, we can tell if the atmosphere contains oxygen, nitrogen, ozone, or even organic molecules. If the planet lies in the habitable zone and its atmosphere shows signs of life-supporting gases, that's when things get exciting. That's how we analyze planets like K2-18b for signs of life. But do these findings prove life exists there? No, finding biogases, water vapor, or oxygen doesn't guarantee life. These compounds could have formed through non-biological processes. Even detecting dimethyl sulfide, a gas linked to marine life on Earth, doesn't mean aliens are burping underwater. And there's always a chance the data is contaminated. After all, we're talking about signals traveling across light years. Interference from cosmic dust, stellar clouds, or other factors could skew our readings. That's why scientists say they've very likely found something, but they won't say they're 100% sure. So, in the simplest terms, we're getting strong clues, but not definitive proof. Still, the possibility of alien life grows stronger by the day. It's not a question of whether life exists out there, it's whether we'll be able to find it. I personally believe in extraterrestrial life, and so do millions of others. Scientists are working on better observational tools to give us clearer answers, and I'm certain someday we will confirm it. Will that day come in our lifetime? I hope so. One of my biggest wishes is to witness the official discovery of alien life before I die. Are we close? Yes, very close, but not quite there yet. Hope you enjoyed this video. See you in the next one. Take care. Goodbye.